In this video, I'm going to help you with an example similar to the homework. We're given here that the functions of f and g are represented by the graph, where the graph of f is this one on here on the left, and g is the one on the right. And our objective is to determine the following compositions. So for this example here, we want to figure out first, because of the order of the composition, we want to work with the inside first and figure out what the inverse of g is at -4. So first of all, the graph that we have is the graph of g and not the inverse of it. So to get the inverse, we would have to get these points, flip them, so we can get a mirror image of this graph across this value, and then we can see what the input value would be to that new graph. But instead of doing that, let's work smarter, not harder. Since all we're doing is switching the x and the y's, let's do that to the graph. Let's switch the labels, and then instead of making this the x value and this the y value for g, because we want to work with the inverse, let's make this the y value and this would be the x value to g inverse, okay? They just simply switch. So instead of switching each x and y, let's just switch again the axes and read the axes in this order now. So to do this part right here, at -4, we're going to look, again, this is the input of -4. So we're going to look at -4 along this line right here and determine what the output value would be by looking at the corresponding position right there, which is going to be the number 5. So this part right here equals to 5. So step 1 is to evaluate that, and we are going to get that the inside of the parentheses is now the number 5. So what we're going to do now with this number 5 is plug that number 5 into the function of f. And because we're looking at the original function f, not the inverse, we don't have to switch anything. This will still be the x, this will still be the y value, and we're going to look at x is 5. So x is 5 is here, and the y value, output value is 6. So the answer to part A equals 6. Now, what about part B? Well, for part B, since we want to now do this composition, we're going to again begin with the inside. So we want to evaluate the inverse of f at -3. So again, instead of getting the image of this and again getting the inverse of that by flipping all of the x values, x and y values, let's just flip again the coordinates. So instead of thinking about this as x and y, instead let's think about this as this axis being the x and this axis being the y. So your x-axis, your y-axis. So since we want to evaluate f, the inverse of f at -3, so using again this inverse axis, okay, we're going to look at -3 along the vertical axis and see what the corresponding point is along the horizontal axis, and we see it's 1. So this part right here equals 1. So we can replace that with 1. So instead of g and this, we can replace, like I mentioned, all of that with 1. And now we're going to use that 1 as the input value for g. And because we're looking at the original function g, we don't have to do the same thing that we did over here, where we're going to read this again, invert it. We can use this as the normal x and the normal y. So no inversion at all. So at x equals 1, we see that the y value is 5. So that is the answer to the second composition. Now, of course, if you're struggling by using this technique, then by all means, switch again your x and y values. Identify what your points are here. So right here, this is -7, -7. This is -3, +1, 2, 3, and 5, 6. And to get the inverse of this, you really don't even have to graph it, as long as you flip again your x and y values. Well, the first one is is the same because both numbers are -7. The second one and third one are the following, and then your fourth point is 6, 5. So you can then just use the table. So you see for the second one, for this one right here, F inverse of -3, F inverse of -3, sorry, I did this wrong. This was 1, -3. Let me fix this. 1, -3. So the inverse of that would be -3, 1 there. Now I have it right. You see the inverse of f at -3. So here's the inverse of f. At -3, we get the value of 1. So you see, that's how I get that 1 there. Okay, so if you don't want to think and look at this graph inverted, where this is the x and this is the y, then just do this. Make yourself, again, identify what the points are. Again, and the more points you have, the better. Find all the pretty points you can find, label them, and then without having to graph it, you could just simply look at invert those and look at the pretty points, because that's obviously what we're using. We're using pretty points on the graph. We're not going to use a point that is not, again, like in the middle right there. Okay, we're not going to look at 2.5 or 2 and try to determine what the y value is or the x value. So look at the pretty points, invert those, and look at the table of that inversion. You could also do it like that. Cool. Again, thank you for watching, and I hope this video was helpful.